Supplemental math videos from Circle Christian School.
Graphing linear inequalities is about graphing all the possibilities. What coordinate can you put into the equation, input-output, that would make it true? A lot of these get used in business because we're trying to figure out what parts of the equation would make it true and make money, and of course, which parts that you'd put in would be not making money.
All right, linear inequalities. So I'm going to bring in my 3 problems here. All right, let's start with the first one. And you'll notice it's not in slope-intercept form, so we're going to have to do the do change. Got my little fence of inequality here. We're going to move the 2x, and anytime that you jump the fence here, remember that basically you're just changing the sign. So I get a negative 2x plus a 12. We're going to divide everybody by a negative 3. And when we divide by a negative in step 3, we flip the inequality. So we have y is greater than 2 over 3 x minus the 4. So now we're going to graph it. Going to start with the negative 4. That's where we begin. It's our y-intercept. Going to follow our slope up 2 over 3, up 2 over 3. Next, we're going to look at the inequality here. That's going to tell us if it's a broken or solid line. Because it doesn't have the equal sign underneath it, it's going to be a broken line. And now we need to know whether we're shading the possibilities up or the possibilities down. You can pretty much disregard what's happening to the slope here and read what it says. Y is greater than all the negative 4's. So right here at negative 4, we're going to do the y's that are greater. So we can see that we're shading up. Greater than, shade up. Less than, shade down. Okay, next one. Same thing. We're going to have to do a change to it. And same thing. We're just going to jump this fence, x over the fence here. And so we get a 3y is less than and equal to a negative x minus a 15. We're going to divide everybody by a 3. No need to flip our inequality here. So we get a negative 1 over 3 x minus the 5. We're going to begin at a negative 5. 1, 2, 3, 4, 5. Our slope says go down 1 over 3. And if you start to run out of room, you can just kind of look at the other side of the steps here. Let's see, it has an equal sign to it, so it's going to be a solid line. Oops, kind of missed one of my points there. But you get the point. Ha, ha, ha. All right, and so we're going to, this says, I'm going to disregard my little slope here, and it says all the y's that are less than the negative 5. And these are y's that are less than. And so we're shading down. Now you can always plug one of these points back into the original equation and see if it does make a true statement. We can also graph horizontal and vertical lines. For instance, y is less than and equal to negative 5 is going to be a horizontal line. Y lines are horizontal. So I'm going to do this at negative 5. It's going to be a solid line because it has the equal sign to it. And then we're going to shade. This says all the y's that are less than negative 5. Less thans are shade downs. All right, the next one is an X line, and X lines are vertical lines. And this one is at 4, so I'm going to go to my X axis here and start at the 4. It does not have an equal sign to it, so it's going to be a broken line. So it's a vertical line. There we go. And let's shade. Oh, let's use something like yellow. And this says all the x's that are greater than the 4. So instead of going along the y-axis, which was either up or down, x lines go left or right. So these are all bigger than the 4. There we go. And that's how you shade inequalities.